Hey, what is going on, guys, and welcome back. In this video, we're going to start and finish section 6 of part 4. It's the last section in this chapter, and we have the last batch of exercises that we're also going to cover in this section as well. So without further ado, let's get stuck in. This section is called More Strings and Lists. We're going to cover a little bit more about strings, how to slice strings, and how to slice lists and other useful methods with lists. The learning objectives for this section is that you will be familiar with more methods for slicing strings and lists. You will understand what immutability of strings means, and you'll be able to use the methods count and replace. And before I continue, I just wanted to show you guys that I already have the exercises for the section up in VS Code. We're starting on exercise 33 up to exercise 38. And if you are unfamiliar with how to get here and that you have installed the TMC extension on VS Code, click on it, click on the course. Make sure you open the workspace because that's what's going to open all these exercises once we actually do open them over here. Right, scroll down to part 4. We did up to exercise 32 in the last video right here. So we need to do exercises 33 down to 38. So just click them, click this checkbox here for all the exercises that you want to open at once. Hit the open button, navigate back to the file explorer, and you should see them all opened over here. All right. So I'm going to move this to the side for now. We're not going to need it until we get to the first exercise. And let's get stuck in with the reading material. All right, so you are already familiar with the square bracket syntax, and you might be used to calling these a different name, but for the sake of this course and the videos that I'm making, I will be referring to square brackets as like that, because some people call them rectangular brackets or just brackets. But for the sake of being specific, we're going to refer to these as square brackets, and we're going to refer to these as the curly brackets or curly braces. So if you're familiar or you have experience in programming prior to watching these videos and prior to following along with this course, you might be familiar with calling these a slightly different name. But just for this video, we're going to refer them as square brackets for these and curly braces or curly brackets for these. Now, we might not see these often outside of using F strings and whatnot, but these are very common in virtually every other programming language as the opening and closing indicators for code blocks. So if you're using if statements, if you're writing functions in languages like JavaScript, TypeScript, Java, C++, we often use these. In Python, we use the colon, but yeah, so we're going to be seeing all these three symbols in this course a lot, but for the sake of simplicity and keeping with semantics for ourselves, we're going to refer to those square brackets as such. Okay, so let's restart. So you're already familiar with the square bracket syntax for accessing a part of a string. Here we have a variable called myString, which is assigned the string exemplary, and we call the print function. We pass the string as an argument, and we want to print out a substring starting from index 3 to index 7. Now remember, in string, when you're slicing with square brackets in Python, when you give the starting index, you will print up to the ending index, but not the actual ending index. And I'll explain this in a second. As you can see down here, it's going to print MPLA. So what does that mean? Well, how does that work? So this is our starting index. Remember, in Python, or just in programming in general, we start counting indexes from 0. So the first letter will be index 0, then index 1, 2, 3. So this is the M. This is index 3. Then we're going to print up to index 7, but not including what is at index 7. So index 3, index 4, index 5, index 6, index 7, right? So this will be our cutoff. So we're going to print everything starting from the M up to the R, but not including the R. And that's how we get MPLA. So this is just a little bit of a refresher. We've gone over this in the past, in sections 3 and 2. But this is just a little bit more of a refresher on that. Now, the same syntax works with lists. Lists can be sliced just like strings. Here we have a variable called myList, which is assigned this list of integers. When we call the print function, passed the list as an argument, and we're slicing starting from index 3 up to index 7. And it's going to print 4612. And again, it works the same way. We're going to start from index 3 up to index 7, but not including what is at index 7. So let's find index 3, 0, 1, 2, 3, which is this 4, which is what's printed here. Then we're going to print index 4, 5, 6, 7, which is the 2. Oh, I'm sorry. Right. Index 3, 4, 5, 6, 7, which is the 4. But we're not going to print the 4. We're going to print up to the 4. So the 2 will be the last thing that we see. That's why we get 4, 6, 1, 2. All right. More slices. In fact, the square bracket syntax works very similarly to the range function, which we covered in the last video, which means we can also give it a step. Here we have a variable called myString again, assigned to the same string exemplary. We call the print function, pass myString as an argument. We're telling Python to start at index 0 up to index 7 and go up by 2 indexes. So this is how we're going to get EEPA. First print index 0, the first E, right, the from exemplary. Then go up 2 indexes and print that. So 0, 1, 2. Boom, print the second E. Then go up 2 more indexes. M, P, right, 1, 2. Boom, print the P. Then go up another 2 indexes. 1, 2. The A gets printed, and this is how we get EEPA when we enter 2 as the step. If we were to just omit this, like we did over here, for example, then it's just going to print EXMMP up to the A over here, which will be in the same way as just writing 071. So let's actually copy this, and we can see it in the Python playground if I just change this to 1. Now we get exemplar, right? If we increase this step by 2, then we get the EEPA. We can increase this step by 3, which I think will just print the E and A, or EMA, right? So we can change this to how many ways. But if we omit this, so if we write 1 is the same thing as just omitting it in general, like that. So these do the exact same thing, right? And then when we change this to 2, that's how you can see it print EEPA. All right, same thing with lists. So here we have a variable called myList, which is assigned this list of integers in ascending order. We call it a print function, passed myList as an argument, and then we're telling Python to start at index 6, down to index 2, and then decrement by 1. So this is going to print our numbers, but in descending order, starting at index 6. So let's find index 6, 0, 1, 2, 3, 4, 5, 6, which will be the 7. So it prints the 7 here. Then we're telling Python to go down to index 2, which will be this 3. So again, our ending index won't be printed, or the item at the ending index won't be printed, but it'll be up to it. So we start with the 7, we print the 6, we print the 5, and then we print the 4, right? And this -1 is what's telling Python to go backwards in the list. Now let's see this also in action, right? So this is how we wanted to decrement. Now, you're probably wondering, well, what happens if I don't put this here? Well, it's just going to print, it's not even going to print anything, right? It's going to return an empty list because we're telling Python to start from index 6 down to index 2, but we're not telling Python how to get there, right? So that's why we have to write this. We have to pass -1 here to tell Python, hey, we want to go backwards. And we can change this, we can make this step a little bit bigger. We can do -2. So it's going to give us the 7 and the 5. Right? We're telling Python start at index 6, which is the 7, print it, go down 2 steps, print that, go down 2 steps again. But at that point, we'll be past we'll be at index 2. So that's why we won't print the 3 here or print the 4. But if we can do -3 as well, we can get the 7 and the 4, et cetera, et cetera. So this is how we tell Python to print backwards. And we can do the same thing with strings as well, right? So if I do here myString is equal to exemplary, then we say print myString, then start from index 2 down to index 0, right? And then -1, and then we get ALPMEX, right? So start at index 6, 0, 1, 2, 3, 4, 5, 6, which is the A, so it prints the A, then go backwards to index 0. So prints the A, prints the L, prints the P, prints the M, the E, then the X. Again, we don't print the actual index at 0, so we leave it as, so this gets omitted. And that's how we get this. Now, it doesn't print it like, it starts from, it prints this as the first thing from left to right. So it still prints from left to right, but it's going in the reverse order. So that's why it might look a little wonky. Now, there's another way that we can also do this if we want to tell Python to just print our string backwards, right? If you remember, we just have to omit both the starting and ending step, and then it's just going to print exemplary backwards. So we're going to see this in a second. All right, so that's how we get EEPA, and that's how we get 7654. If we omit either of these indexes, the operator defaults to including everything. Among other things, this allows us to write a very short program to reverse a string. All right, so here, my string is a input that we prompt the user for, then we print, we call the print function, pass that string as an argument, and then we omit the starting index, we omit the ending index, and we just tell Python to go backwards in our string. And that's how it's going to print exemplary, right? So if we provide exemplary as a string, it's going to print it backwards like how we just demonstrated over here. Now, if you're wondering, well, how else can we do this the long way, right? How can we print my string without using this shorthand? Maybe that's just something that you want to know. I'm going to duplicate this line here. Again, if you remember our shortcuts that I've been teaching all course long, if you hold Alt, Shift, and press the down arrow key on your keyboard, it's going to duplicate whatever line that your cursor is currently on. So that's another way you can do that. And if you press Control Shift K, it will remove that that line as well. So here, we just need to get the length of the string -1, because remember the length of the string is always one integer larger than the index. So we want to tell Python start at the last index. Now this kind of way is really cool if we don't know, if we're writing a function, for example, and we never know how long that function is going to be. I mean, that string that we're going to be using is going to be. So this is how we can target that very last index regardless of how long the string is. Now, you're probably thinking, okay, we want to print exemplary backwards and the full string. Now, you might be thinking we should pass 0 here, right? And hit run. Let's see what happens. Well, it doesn't. It prints our string backwards, but it omits that very last letter. Now, if you remember, as I mentioned earlier, when we tell Python the ending index, right, then it's going to omit that final index, right? It's going to print everything up to it. So how do we get it to print our full string? Well, we just omit that ending index, and Python is going to automatically infer that we want to print the whole string. And again, we're giving it this -1 step, which is telling Python to go backwards, right? Print our string backwards. Now, if we run this, we get exemplary printed in full in reverse order. So this is this, right? This is this shorthand extended just a little bit. So again, the anatomy of this, right? Grab the length of the string, subtract 1, which will give us the final index, which is this y. Then omit the stop index, right? Because we want to print the full string, and then tell Python we want to go backwards. So that's what this is. Now, this, right? This slightly longer version is what can be condensed down to this, right? Omit the starting index, omit the ending index, just print it going backwards. So these are what these two are equivalent to each other. All right. Okay, warning, using global variables within functions. We know it is possible to assign new variables within function definitions, but the function can also see variables assigned outside of it in the main function. Such variables are called global variables. Using global variables from within functions is usually a bad idea. Among other issues, doing so may cause bugs which are difficult to trace. Below is an example of a function which uses a global variable by mistake. Here we have a function called print reverse. Again, the anatomy of defining a function, you use this def keyword or short for define, provide the function name, opening and closing parentheses in which we define what parameters this function is going to work with. In this instance, the parameter name is called names, which is a type of list. We can infer here that the list will be containing names. Okay, we have here, this is not part of the anatomy of a function, but it's just a useful thing to have. It's a comment. This is how you write comments in Python using the pound symbol or the hashtag symbol. Here we have a variable called I, which is equal to the length of the list minus 1. So we want to get the last index. Then what we say, well, I is greater than or equal to 0, print that name, and then decrement I by 1. So we want to print the list of names backwards, right? Start from the last index to the first. Okay, here the global variable is assigned. We have a name list, which is a list of all these names: Steve, Jean, Catherine, and Paul. Then we call print reversed, and we passed a name list. And then we call the print function to give us a space here. And then we call print reversed again, and we pass another list. So here we print Paul, Catherine, Jean, and Steve. And then again, it prints Paul, Catherine, Jean, and Steve. So even though both functions calls have the right kind of argument, the function always prints out what is stored in the global variable name list. Again, as you can see, in our function, right, we told Python that we're going to be getting some sort of list, right? It's a variable, a parameter called names, which is going to be a type of list. But as you can see, right, we're not referencing names here. We're referencing name list. So Python is going to go and look for name list, and it's going to find it here in the global variable. So no matter how many times we call this, the function is always going to be working with this variable name list within it, instead of any generic list that we pass into it that contains some string values or whatever list that we pass into it, right? So that's the issue of using global variables in local scopes, right? In function scope. So we have to be careful of that. To make matters even more muddled, remember that all code for testing your functions should be placed within the if name equals main block for automatic tests. The previous examples should be modified. So here, again, our function, then we set this block that makes sure that all our tests are run inside of this block. Notice the global variable is assigned within the if block now. The automatic tests in the TMC system are executed without running any of the code in the if block. So in this latter example, the function wouldn't even theoretically work, since it refers to the variable name list, which doesn't exist at all when the tests are executed. Right, so because this now the name list variable exists in this if block, this function doesn't have access to it anymore because it's locally scoped, right? The scope of this function is local. And the scope of this name list variable is also local. So even if we do pass name list here, this function is looking for the globally scoped variable called name list. So it's not even going to be able to access it because it only exists locally in this if block. So I think we can try and test this in the Python playground. So let's run this and see what happens. Okay, so it still runs, surprisingly, but I think in our case, because of how the TMC tests are configured, this will not work. So it works here because Python sometimes will let you play with scoped variables regardless, but yeah, in the TMC setup, this will not work. Now, why this works is because Python doesn't introduce new scopings or new scopes when variables and whatnot are declared using control blocks. So if statements so what are control blocks? So if statements, loops, so while loops, for loops, and things like that, they don't introduce new scopes. So what Python here is going to do is it's going to look at the global scope in the entire file, right? The scope in the entire file and it's going to find name list, right? Now, if you're coming from other programming languages, this might be counterintuitive. In Java, for example, in JavaScript, TypeScript, I think even in C++, it doesn't work like this. Whatever you define inside of control blocks, right, conditional blocks, loops, functions, classes, they exist in that module, right? They exist just where they're being defined. They don't exist unless they're actually defined in a global scope. But in Python, it doesn't work like that. Now, if we were to define name list inside of a function, for example, or a class, then we wouldn't be able to access it anywhere else. But if you define it inside of an if block like this, then Python still has access to it. That's why this works, right? Now, in the TMC environment, this will not work because the way the tests are configured is purposely to ensure that you don't make this mistake, right? That you don't use scoped variables in outside of their scope or use global variables in scopes, in local scopes and whatnot. But but Python as a language, right? This is one of those quirky features that it has. So anything that you define inside of a conditional or a control block, like an if statement, a loop of some sort and whatnot, is still accessible. You can still access it outside of that conditional or control block. But if it's defined in a function or a class, for example, then you can't access it outside of that scope. So this is why this works. So hopefully that made sense and why I felt like I had to explain that because I don't want people thinking that, hey, you can just do this wherever. It's true that you can do this wherever when a native Python environment is running, but on the TMC side, right, on VS Code with the TMC extension, you can't do that. But this is why that works. Okay, notice the global variable is assigned within the if block now. The automatic tests in the TMC system are executed without running any of the code in the if block. So in this latter example, the function wouldn't even theoretically work since it refers to the variable name list, which doesn't exist at all when the tests are executed. Okay, here we get to our first exercise called everything reversed. It says please write a function named everything reversed, which takes a list of strings as its argument. The function returns a new list with all of the items on the original list reversed. Also, the order of items should be reversed on the new list. An example of how the function should work. Here we have a variable myList, which has these strings. We have a variable called newList, which calls the everything reversed function, passes myList to it, and then we print a new list. So each item in the list is reversed, and the items themselves are in reversed order. Okay. Let's open up VS Code. Here we have the source file already open. I'm just going to navigate to it by doing CD for change directory, go back up one folder, give it the folder for exercise 33 name, everything reversed, then into the source folder like that. Now, if I was to say print hello world like this and save, then I do Python everything reversed .py, and it's going to print hello world. So I'm going to be running Python manually in the terminal here, but if you have the Python extension enabled on VS Code, you should see a little run button up here. If you click that, it's going to automatically run whatever file that you're currently working in. So that's just what we're doing here. If I have any more extensions open, VS Code is going to croak, and this video is going to progress much further. Okay, anyways, so we're going to define a function here. Actually, in fact, we're going to do if name is equal to main. Then we're going to copy this, paste it here, indent everything, save. Then up here, we're going to define a function called everything reversed. Here we're going to take in myList, which is going to be of type list. Then we're going to create a new list. Or we're just going to be careful and say return list equal to an empty list. Then we're going to do a for loop and say for item in my list then we're going to do return list dot append append, and then we're going to do item like that. Then we're going to return list. Now let's run this and see what it does. Okay, we get an issue. Oops, forgot the -1. Let's clear this, run it again. Okay, we have a typo on the function named. There we go. Do it one more time, and there we go. So now we get high, right? Everything here is in reverse order. Right now we need to reverse the order of our return list. So let's just create some spacing here. Then we're going to say for item in return list. Then we're going to do, actually no, we can even do it this way, right? We can do return list, slice it like that, and then like that. So now it's going to return our list in reverse order. So let's run this and see what happens. And there we go. So we get the strings are reversed and the order of the items in our list is also reversed. And that should be the solution to that. Again, if you want to do it the long way, you can. I think we'll do what? Length of return list -1, omit the ending index, and then tell Python to go backwards. Let's run this again. And again, we get the same result. So you can do it this way. I'm going to comment this out and duplicate it here so you can have that in the GitHub repository. It's going to have all the solutions that we covered here. So you can look at an alternative solution. Okay, so that's it. Let's hit the TMC test button. All the tests passed. Send that solution to the server so we can get credit for that. Okay, and then I'm going to hit show model solution in the browser. Hit open. I'm going to log in here. Give me 1 second. Okay, and there we go. So here, do the same thing. They defined a function called everything reversed, which takes this parameter myList, which is of type list. Right? I mean, it's prompted as of type list. Define a new list variable. Then for myString in my list, append it. So append the item reversed, and then return that new list reversed. So they did the same thing here. They did it inline just like we did. If I open our solution here, right? So reverse the item in the list, then return the list in reverse order. If you go back to the course website, hit refresh here, make sure that you get credit for this. So always hit the refresh button once you submit from VS Code to get this green background on the exercise window and 1 out of 1 points to make sure that you get credit for that. Okay, strings are immutable. Strings and lists have a lot in common, especially in the way they behave with different operators. The main difference is that strings are immutable. That means they cannot be changed. So here we have a variable called myString, which is assigned the string exemplary, right? And if I do myString using square brackets to target index 0 and set that equal to A, right? This isn't going to work, right? I can't target a specific index and then change what value is in that index like this. Right? Strings cannot be changed, so the execution of this program causes an error. We get this type error. String object does not support item assignment. A similar error follows if you try to sort a string with the sort method. Strings themselves are immutable, but the variables holding them are not. A string can be replaced by another string. The following two examples are thus fundamentally different. Here we have a variable called myList, and it's assigned this list of integers. Then we can mutate, or we can change specific values in these specific indexes in our list using square brackets. So we can do my list at index 0, set that equal to 10. And now if we do this, if we print this, well, my list is originally going to have 1, 2, and 3. Then when we do change index 0 to 10, now my list is going to have 10, 2, and 3. Here we have my string is equal to hey. Then we have my string is equal to my string plus this exclamation point. Right, so here my string first prints hey. Then we do this, then my string now points to hey with the exclamation mark. Now, while the result, now we can, this is string concatenation, right? We're not changing indexes, we're concatenating a value to our existing string. Now this we can do in Python. The first example changes the contents of the referenced list. The second example replaces the reference to the original string with a reference to another string. The original string is still somewhere in the computer memory, but there is no reference to it, and it cannot be used in the program any longer. So again, this is one of the things that you have to think about in Python. Variable names reference a value that is stored somewhere in memory. So when we do my string is equal to hey, and then my string is equal to hey, concatenate this exclamation point, right? We're not mutating, we're not changing that original spot in memory that my string was pointing to. Now what it's doing is it's creating a new spot in memory, and my string will be pointing to that new spot. Now this hey still exists somewhere in the computer memory, but we just can no longer reference it, which is what our variable names do in programming. They reference something, right? They're not directly assigned that item, right? My string, and our computer doesn't know what my string is per se, but it does know that my string references a specific spot in memory in which this string hey is being written. It was written to. So hopefully that makes sense. This is some of that computer theory, computer science stuff. If you've taken computer science courses, this is one of those things that you learn in when you're working with memory. And if you take computer programming courses, you will learn these terms, right? Pass by reference versus pass by value. And so if you're defining a function, for example, and a function that works with integers, right? You can assign a parameter named that will occupy the space of that integer. But when you call the function, you're going to pass an integer. You're not going to pass a variable to it, right? You're going to not going to pass a reference. So we'll work with this, for example. So here, if I have number, which is a type of integer, for example, or it should be int, like this. So if I say print number, now in here I can do, like say print reversed, and then I can pass 10, for example. And if I run this, it's going to print 10, right? So what I'm passing here is an actual value. It's a data type. I'm passing 10 directly to the print reversed function. Now this is what's called pass by value. But I can also do this, right? I can just say here num is equal to 10, and I can say print reversed, and then I'm going to pass num. Now if I hit run, we still get 10 printed. Now this is what's called passing by reference, because variables reference values stored in memory. So when we pass the integer name here, for example, we're passing that reference, and then Python is going to find what num points to in memory. So this is passing by value when we're calling a function, and this is passing by reference when we're calling a function. So this is what this is talking about. Now this is the layman's way of explaining this stuff. I mean, it gets pretty complicated if you've taken computer science courses in the past at a college level. When they start talking about memory and passing by reference, passing by values, you dive a little bit deeper into that. If this is a topic that interests you and you want to learn more about it, let me know in the comments below, and I will make a separate video about this kind of stuff. But yeah, so this is what's happening here. We're changing the reference, what my string is referencing to. Okay, we will return to this subject in the next part where references to lists are explored in more detail. So we will cover this actually in part 5. So awesome. We might not even have to jump the gun and start talking about this right now. Okay, more methods for lists and strings. The method count works the number of times the specified item or substring occurs in the target. The method works similarly with both strings and lists. Here we have a variable called myString, which is assigned this string, how much wood would a woodchuck chuck if a woodchuck could chuck wood. It's one of those tongue twisters. Here when we call myString, print, we call the print statement and we pass myString as an argument, and we chain this count method to the string, and then we pass the string ch, then Python's going to traverse our string and look for every single time the substring ch appears. So we see it here, which is once. We see it here, which is twice. We see it here, which is third time. We see it here, which is the fourth time. And we see it here, which is the fifth time, which is why we get 5 printed down here. Here, same thing. We have a variable called mylist, which is pointed to this list of integers. Then we call the print function, pass mylist.count as an argument, and we pass 1 as what we want to find how many times appears in the list. It prints 3, so let's look for it. 1 is printed here once, it's printed here the second time, and it's printed here the third time, and that's how we get 3. The method will not count overlapping occurrences. For example, in the string AAAAA, the method counts only 2 occurrences of the substring AA, even though there actually will be 3 if overlapping occurrences were allowed. So what does this mean in terms of overlapping occurrences? Right, if we're looking for AA, then this will be the first occurrence, this will be the second occurrence, this will be the third occurrence, right? As you can see, this and this overlap, right? This, what will be the second A in this substring and the first A in this substring overlap. Same thing here. What would be the second A in this substring is the first A in this substring. They overlap. But the count method is just going to do AA, stop, and then AA, stop. So that's why we get 2 instead of 3. Okay, so hopefully that makes sense. We could, just try and see it here in the Python playground. Then if we do print myString.count AA like that, we get 2, right? Instead of 3, right? Because overlapping isn't taken into account when you're using the count method with strings. Or just with strings with lists and whatnot. It's just going to traverse the string, look for the first instance of AA. It's going to say, okay, so this is the first instance. Then it's going to start basically again counting from here onwards. It's not going to traverse it the first time, found the first instance, then traverse the string a second time and found the second instance, traverse the string a third time and print the third instance. It's only traversing the string once, so it's looking for each time we see AA in that one traversal. So it's going to see AA first, then it's going to see AA second, and that's why it's going to return 2. The method replace creates a new string where a specified substring is replaced with another string. Here we have the variable myString, which points to the string hi there. Then we have another string variable called newString, which is myString that replace hi with hey. So when we print newString, instead of printing hi there, it's going to print hey there because we replaced hi with hey from the original string. Now this still exists. We can still print hi on myString and it will still return hi there. In fact, let's see this on the Python playground here. So when we do this, right, we're going to get hey there. But we can still do this. And we're still going to get hi there because we haven't changed what myString points to. myString still points to hi there. We haven't changed the reference for myString. We just created a new variable that uses myString and then replaces hi with hey. So the replace function, you can give it a specific value in the string or substring in the string that you want to replace it with. But again, if you remember, strings are not mutable. So, we can't say just return my string replaced with hi and hey, and then my string is going to point to hi there. Hey there instead of hi there. Okay, the method will replace all occurrences of the substring. Here we have a variable called sentence, which has another tongue twister. Sheila sells seashells on the seashore. And when we call the print function pass sentence as an argument with the replace method, we replace she with a capital SH she. So here, the first occurrence of she gets changed to capital letters. Then we find a second occurrence here, changes it to capital letters, and then there's no more occurrences. Remember, these functions replace and count, they only traverse the string once. So that's why, again, overlapping isn't being taken into account. When using the replace method, a typical mistake is forgetting that strings are immutable, which is what I was just talking about. Right? My string Python is fun. And then here, we're telling Python to replace Python with Java. But when we print my string, it still prints Python is fun, right? Because this replaces the substring, but we have nowhere to store this replacement, so we can reference it. If the old string is no longer needed, the new string can be assigned to the same variable. So this is why this works now, which is going to print Java is fun, right? So here you have my strings that go to Python is fun. Then we tell my string, hey, point to a new position in memory, right? Where we replaced Python with Java. And now my string will point to that new reference. And that's how we get Java is fun. Okay, here we have an exercise called most common character. It says please write a function named most common character, which takes a string argument. The function returns the character which has the most occurrences within the string. If there are many characters with equally many occurrences, the one which appears first in the string should be returned. An example of expected behavior. Here we have a variable called first string, which is A, B, C, D, B, D, E. When we print the most common character and we pass first string, then it's going to print B, because while B and the letter D appear twice in the string, B was the first one that we saw, that Python saw first, that it appeared twice first in the string when it traversed it. Right? So it sees it here first, then it sees D, sees B again before it says D. So our function is supposed to return the first, whatever letter was seen first. Okay, here we have another variable called second string, exemplary, elementary. When we print the most common character, right, E appears way more times than A, way more times than L, way more times than Y. So that's why we get E. Okay. I have VS Code here opened up. Already navigated to the second exercise folder. And I've also done the same thing in the terminal. So if you haven't done that already, make sure you do that. Again, just change directly back up from the source folder, from the exercise folder, then go into part 04, 34, ... and then go into the source folder so we can be ready to run the function. Again, if we just do print hello world from common character, just to make sure that we're in the right folder, and also do Python most common character, and then there we go, hello world from most common character. Okay, so first things first, we're going to do is do the if name is equal to main, and I know we need to, just gonna copy this, gonna paste it here. We're missing an F here. That way we can copy this, use that as the function name, and we're going to call the parameter my string, prompt it as of type string. So what I'm thinking is we're going to need I mean, obviously, we're going to need to track. So the objective is to track how many times a letter appears and to return that letter. And if more than one letter appears first, then appears the same amount of times, then send the first one that you see as the result. So I'm going to define a variable here called best character. I'm going to abbreviate character to char. We're going to set that equal to the first string, the first character in the string that is going to be passed into this function. Because we're going to be traversing the string, so this best character is going to always change, right? So that's what, right? It's the best case scenario is to just assign the first character in that string to be the best character. And then we're going to also keep track of the best count, set that equal to 0. So this is going to be how many times our best character appears in our string. So the first time, we're just going to set that equal to 0. Okay, now we're going to need a loop. We're going to do a for loop. So we're going to say for character in my string, then set the current count to 0. Okay, so this is how we're going to be keeping track of the characters that we encounter when we're traversing the string using this current count variable. We're going to need a nested loop. So we're going to create another loop inside of our for loop here. So for the next card, which is going to be next character, right? So we're going to be comparing this character, right, the first character that we see, to every character that comes after it. So that's what this nested for loop is going to do, right? For each time that this loop runs once, our nested loop is going to run a bunch of times, or basically for the length of the remaining of the string. So hopefully that makes sense. So in my string, then we're going to say if character is equal to the next character, then change the current count equal to current count plus 1, right? So if the next character in line following this first character that we're looking at is equal to this character, then increment this current count by 1. So this is what we're doing here. Now this is going to run every single time, basically for the next, until we get to the end of the string. Okay, and then here we're going to say, if current count is greater than the best count, then we need to set best count equal to current count. And we set best character equal to the character. So what's happening here? So first, our loop is going to run once, right? It's going to target the first character first. We're going to set the current count of that character that we're just looking at right now to 0. Then we're going to say, hey, call another loop inside of this, in which we're going to be looking at every character that comes after the current character that we'll be looking at. So if that next character in line is equal to the first character that we're looking at, then that means we can increment the current count, or basically how many times that we're seeing it, by 1. Now this is going to run again for the entirety of the string, and then we're going to check if the current count is bigger than the best count, set best count equal to current count, and set best character equal to this character. So essentially, we've seen this character now a bunch of times, so set that equal to the best character, and set that equal to the best count. So however many times that we've seen it. Now remember, with for loops, we don't have to manually increment character, whatever iterator variables that we're using. It's going to do that for us. That's why we don't have to worry about that here. But this is what it's doing. Basically, hey, loop through the string for that first character that we're looking at, set that equal to the best of the best, right? Which was happening here. Then call a nested loop, and then look at every character after that one. And if it's equal to the first character that we're looking at, set and update those variables, right? Update best count, update best character, so that character now becomes the best character, and best count becomes the best count. Okay, and then it's going to run the loop again. So first, this character is not going to become the second character in line. And it's going to do this over and over and over again until we run through the entire string. So hopefully that was an easier way to explain it. I didn't prepare a diagram for this exercise, but hopefully you can make some sense of what I'm talking about. If not, then I could make another video talking a little bit more about this exercise. Then we're just going to return the best character because that's what we're concerned about the most. We just want whatever the best character is. Save. Now, if I was to run this, we should see B and we see E. Now, if we go back to the browser, the best character for A, B, C, D, E, A, B, C, D, B, D, E, I mean, is B, because while it appears twice, same amount of times as the letter D does, the letter B appears first. So that's why we return B. And for E, it's clearly the most, I mean, for this string, E is clearly the most recurring character in this string, so we'll return E. So if I open OP, back to VS Code, hit the test button, there we go, send that solution to the server, so we can get credit, go back to the browser, refresh, make sure that we got credit for that, show the model solution, and there we go. They did the same thing. They just didn't use as many tracker variables as we did, but they did do actually no, they didn't do nested loops. Wow, that's clever. So here we have a variable called most common, which is assigned to the first string. I mean the first character in our string, like we did here. Then they call a for loop. So for character in my string, if my string.count character is greater than my string.count most common, this is even neater. So basically, they're using the count function here to count how many times the current character appears in my string. Then, if the amount of times it appears is greater than the first string that we've seen, the first character that we assigned most common to, set most common to character and then return most common. So, yeah. So now this is a working solution, but we didn't take advantage of using the count and replaced functions that strings have. So I would copy this and I'm going to put it here, but I'm going to comment it out. Oops, excuse me. So we should probably just do this. So this is a way better solution. In fact, actually, I'll comment out my code and return this. This is way better because it uses the count function. So yeah, I would definitely give props for this. I definitely over-engineered my solution, but both solutions work, but this one is way neater because it takes advantage of the count variable that we just learned about. Okay, so let's continue. Here we have another function called no vowels allowed. Another exercise called no vowels allowed. We're told to please write a function named no vowels, which takes a string argument. The function returns a new string, which should be the same as the original, with all vowels removed. You can assume the string will contain only characters from the lowercase English alphabet A through Z. An example of expected behavior. So here, my string, this is an example, right? My string removed all the vowels E, A, and A. Okay, so let's navigate to this folder. Part 35, exercise 35 folder. I'm just going to change directory by 04-35 and then no vowels allowed into the source folder. We can close this, open up this file, define a function called no vowels. Is that what it was called? Yes, it was called no vowels. Vowels, which takes in a string. Then down here, I'm going to do if name is equal to main. I'm going to paste that. Okay, so we want to target all the vowels. So we're going to say for character in my string, in fact, here we should probably do return string is equal to an empty string like that. If Okay, I had an issue. Wait. Okay, I had an issue. I'm assuming I had too many tabs open on VS Code, so my frames spiked like crazy. I had to let them come back down. Um, so where were we? So we can do it for character in A, E, O, U, right? The vowels. Then we can do my string is equal to my string dot replace character like that. Then return my string. So now let's run this. All right, there we go. It works. Um, yeah, I had to re-record this little last part because like my frames shut up insanely high on OBS. But yeah, so this is basically it. Now, instead of looping through my string, let's loop through the vowels that we want to remove from the string. Then we're gonna say, hey, traverse that string, and anywhere that we find any of these letters, A, E, or U, right, replace them with an empty string. Now we can be even, more semantic here and change this to vowel because this string is a string of vowels. So we can say for vowel in A, E, or U, then replace vowel with an empty string. So now when we run this, there we go. We get this is an example. So let's run our tests. Send that solution to the server. Come back to the browser, refresh, get credit for that. I need to close this. Send show model solution in the browser. And look at that. So we did it even a little bit cleaner. They didn't use the replace function here, which is surprising. So I guess we're flipping back and forth. Well, we don't use the replace function in one solution. They don't use it in another. So they did it this way using a nested for loop. Using a for loop. Then if letter not in vowels, then return result plus equals letter. What we did is traverse through the vowels string and replace the vowel that we find in our past string with an empty string. And then we return my string. All right, cool. So let's keep going. Here we have another exercise called no shouting aloud. It says the Python string method is upper returns true if a string consists of only uppercase characters. Some examples. So when we call print xyz that is upper returns true, but if we do is it upper is equal to abc, right, capital A but lowercase bc that is upper, and then we print is it upper, we get false. It says please use the is upper method to write a function named no shouting, which takes a list of strings as an argument. The function returns a new list containing only those items from the original which do not consist of solely uppercase characters. An example of expected behavior. So here we have a list of strings. We have a mixed strings of uppercase and lowercase letters. Then we just want to return the list of only the lowercase letters, or even one that's capitalized but doesn't include all uppercase letters. Okay, so let's go to VS Code. Gonna close that and navigate to exercise 36 source folder. Change directory into part 04-36- no shouting allowed \source. Okay, open this folder. As per usual, print hello from exercise 36. Run the file. There we go. Hello from exercise 36. So this is how the expected behavior. So we're going to do if name is equal to main. Paste that, indent. Then here we're going to define a function called no shouting my list, which is a list. Then we're going to do for item in my list if item that is upper, so we're going to say return list, or we should say new list, is equal to an empty list. For item in my list, if item that is upper equals to true, then I should say if not, then new list dot append item return new list. So let's run this. There we go. We get def, lower, another lower, and capitalized. If we run the tests, send that solution to the server, show model solution in the browser. There we go. Open an empty list without upper. For string in list, if not string that is upper, then append that item to the list, then return the new list. I'll go back up here, refresh, make sure we get credit for that, and we do, and we can keep moving on to the next one. Given a list of integers, let's decide that two consecutive items in the list are neighbors if their difference is 1. So items 1 and 2 will be neighbors, and so will items 56 and 55. Please write a function named longest series of neighbors, which looks for the longest series of neighbors within the list and returns its length. For example, in list 1, 2, 5, 4, 3, 4, the longest list of neighbors will be 5, 4, 3, 4 with a length of 4. An example function call. Okay, so here we have a list called myList, has its integers 1, 2, 5, 7, 6, 5, 6, 3, 4, 1, 0. So we can, just with the eye test, we can see that this will be the longest neighbor. And then here print the longest series of neighbors, which will be 4. Okay, so let's go in VS Code. Navigate to exercise 37 folder. Oops, I did not mean to do that. Zero 4 37 neighbors in list source. Oops, what happened? Neighbors in, I spelled neighbors wrong. They spelled it like that. Spelled it wrong again. Huh, what's going on? What am I spelling wrong here? Neighbors in list, right? Okay, got it to go. And as per usual, we're going to open the source folder here, print hello from exercise 37, just to make sure that we're in the right folder. Python neighbors in list.py, and there we go, hello from exercise 37. So I'm going to copy this. If name is equal to main, like that, save that, and we're going to define a function here. So set count is equal to 0. We say for number in my list if number plus 1 I gotta think about this. So we need to get the series of numbers that are closest to each other in consecutive steps. And closest to each other meaning what their values are. So, right, 5 to 4 is -1, and 4 to 3 is -1, and 3 to 4 is minus 1, etc., etc. So, right, this will be the longest series, right? Because here 1 to 2 is plus 1, but 2 to 5 is plus 3. So this is not going to work. So that's what we're supposed to do. So I restarted this. So set longest is equal to 1 and current equal to 1. So we're going to be using these two variables to track the longest series and the current series. Actually, no, we shouldn't even use the list itself. Range 1 length of my list. So start from 1 to the end of the list. Wow, this is a lot more tricky than I thought. Okay, so I was trying to, in my head, to think of the best way that I can explain what I'm thinking in my brain. So the longest variable here is referencing the length or the series that has the closest neighbors. And current will be that current series that we're examining. So for example, we start from 1, that's from 1 to 2, that would be the current longest and the current series that we're looking at. But once we get to 5, we'll realize that series is over. So then this will be, actually not this, because 5 to 7 is not within 1. But 7 to 6, for example, will be the next longest series. And then the next current series that we're looking at. So that's what we're using longest and current. So here what we're going to do is check if the absolute value of the current index for my list minus any value previous to that is equal to 1. And we use absolute value because in some instances, the difference in neighbors could be minus 1 instead of plus 1. So here we see 7 to 6 is minus 1, 6 to 5 is minus 1, and 5 to 6 is plus 1. So we need to take account into both situations, whether the difference is minus 1 or plus 1. That way, we're going to then do increase the current series by 1. So here we're going to do plus equals 1. And then increase the longest by changing, by getting the list that includes where we're currently at to from where we started to where we're currently at. So now we're going to do longest to current. Again, we've seen this max function in the past when we started learning about lists. Otherwise, we're just going to say, hey, set that current back to 1, and then down here, return longest. So that's it. So we have learned absolute values in Python, but we haven't learned about the absolute value function. Now, if you go to the TMC website, this exercise, not this one, exercise 3, well, this is my submission, but the exercise number is 306470. This is the URL. You can copy and paste it and see if you did this exercise. This is from all the way in part 1. But if you look at the details, right, the exercise was asking us to, for any number that we get, return the absolute value of that number. So this is what the absolute value function is doing, right? There's an absolute value function that exists in Python natively. Again, it's one of those cheat codes. Again, I don't know why we haven't learned this yet, but I'm showing it to you now. This is what we're doing here because, again, our lists, the series or the neighbors can differ by -1 versus being +1. Right? We can see here 7 minus 6 is -1, but the difference is still 1. So we need to get the absolute value of that so that it can always be a positive 1. And then we can use that to track the length of the longest series. So then if we go down here and we run that code, and there we go, we get 4 being returned when we have our list with these integer values. So we can hit the test button up here, send that solution to the server, open that model solution in the browser, and there we go. They did pretty similar to what we did. Again, get the absolute value, increment the result, return the result. Otherwise, reset the result to 1, then set longest is equal to this, and then return longest. So very, very similar to what we did. But yeah, gonna close these extra tabs here. Actually, we'll leave the Python playground open. Make sure we refresh this to make sure that we got credit for this exercise, and let's keep going. Okay, here we're getting into developing a larger programming project. This fourth part culminates in a slightly larger programming project where you get to apply many of the techniques learned so far. Rule number 1 in tackling any programming project is not trying to solve everything at once. The program should be built out of smaller sections, such as helper functions. You should verify the operation of each part before moving on to the next. If you try to handle too much at once, most likely only chaos ensues. To do this, you will need a way of testing your functions outside the main function. You can achieve this by defining a main function explicitly and calling this function from outside any other function in the program. A single function call is then easy to comment out for testing. The first steps in building the following programming project could look like this. Define the main function, define a list, and then the rest of the program goes here, and then we call main. Now the helper functions can be tested without running the main function. Here we can define a function called grade, which takes in points, and so on and so forth. And then down here's how we test out the helper functions. Okay, passing data from one function to another. When the program contains multiple functions, the question arises, how do you pass data from one function to another? The following example asks the user for some integer values. The program then prints out these values and performs an analysis on them. The program is divided into 3 separate functions. Okay, so here we define a function called input from user, which takes in this parameter called how many, which is of type integer. We print, please type in how many numbers, and then for I in range, we prompt the user, and then we append that prompted value to the numbers list. Then we return the numbers list. Here we define a function called print result. We pass numbers. The parameter is numbers, which is a type list. Then we print the numbers are, and then for number in numbers, print number. Here we have another function called analyze. Again, takes in numbers, which is a type list. And then we get the mean from the list, and we return this print statement. So here inputs is equal to input from user. Then we call the print function and we pass inputs. Then we call analysis result, calls the analyze function, which passes inputs as well. And then we print analysis result. When the program is executed, it could look like this. Prompts the user to type in 5 numbers. They type in these 5 numbers. Then those numbers are read back. And then those numbers are, we get the mean, the smallest value, and the greatest value. The idea here is that main function saves all data processed by the program. In this case, all that is needed is the input from the user in the variable inputs. If the input is needed in a function, it is passed as an argument. This happens when the functions print result and analyze. If the function produces data that is needed elsewhere in the program, the function returns it with a return command, and it is stored in a variable in the main function. This happens when the functions input from user and analyze. You could use the global variable inputs from the main function directly in the helper functions. We have already covered why that is a bad idea, but here is another explanation. If functions are able to change a global variable, unexpected things may start happening in the program, especially when the number of functions grows large. Passing data into and out of functions is best handled by arguments and return values. You could also separate the implicit main function in the example above into its own function. then the variable inputs would no longer be a global variable, but instead a local variable within the main function. And if you remember from earlier what I mentioned, any variables defined within functions are scoped to that function and cannot be accessed outside of that function. In this exercise, you will write a program for printing out graded statistics for a university course. The program asks the user for results from different students on the course. These include exam points and numbers of exercises completed. The program then prints out statistics based on the results. Exam points are integers between 0 and 20. The number of exercises completed is an integer between 0 and 100. The program keeps asking for input until the user types in an empty line. You may assume all lines contain valid input, which means that there are 2 integers on each line, or the line is empty. An example of the data is typed in. Prompt the user over and over and over until they enter an empty string. When the user types in an empty line, the program prints out statistics. They are formulated as follows. The exercise completed are converted into exercise points. So they are completing at least 10% of the exercises grants 1 point, 20% grants 2 points, and so forth. Completing all 100 exercises grants 10 exercise points. The number of exercise points granted is an integer value rounded down. The grade for the course is determined based on the following table. So 0 to 14, you get a grade of 0. 15 to 17, you get a grade of 1. 18 to 20, a grade of 2. 21 to 23, a grade of 3. 24 to 27, a grade of 4. 28 to 30, a grade of 5. This is also an exam. There is also an exam cutoff threshold. If a student receives less than 10 points from the exam, they automatically fail the course, regardless of their total number of points. So statistics points average 14.5, pass percentage 75, grade distribution 5, 4, 3, 2, 1, and 0. Okay, so this is a very loaded exercise. You have to first split the input and then convert the sections into integers with the integer function. Splitting the input can be achieved in the same way as the exercise in the first, second, and last. But there is a simpler way as well. The string method split will chop the input up nicely. You will find more information by searching for Python string split online. The program asks the user for results from the different students in the course. This includes exam points and numbers of exercises completed. So I'm assuming the first value will be the points and the second value will be the number of exercises completed. So you know what I'm going to do? I'm going to do this in a separate video. I think that will be a lot easier to tackle because this is a very loaded exercise and I think it deserves its own video to talk about it. So that's what I'm going to do. In the next video, we'll cover exercise 37, or what is this, exercise 38? Yeah, 38. We'll do exercise 38 in a separate video. I think that will be a lot easier than doing it all in one video because this is one of those issues, again, that I have with this course. Is sometimes they do things a little unorthodox. I think we needed to build up to doing a large program like this, right, by experimenting or having exercises that ask us to define several functions and then using those functions in a main function. So I think that this is going to definitely deserve its own video. So I'm going to do that in a second video, which will be uploaded right after this one, or within a day of this one, in which we solve this final exercise. I would have liked to do this in one video, but I think that this video will go on for like 2 hours long. So I think it's better if we do that in a separate video. So keep an eye out for that one. It should be uploaded, I think, within 24 hours of when you see this video. So thank you so much for watching. If you have any questions of anything we've covered so far in this video in particular, please let me know in the comments below, and I will try my best to address those questions and concerns. If not, just, again, keep an eye out. The next video will be covering exercise 38 in great detail. All right, I'll see you guys in the next video.